All right, we're back with another video. This time about angles and their relationship in triangles. We got 5 new theorems to absorb in this topic, and so let's get started. Here's one of our most important theorems that we know, most well known. You see a picture of triangle ABC, and here's the theorem. It's called the triangle angle sum theorem, and the theorem states that the angle sum of a triangle is 180 degrees. So you're given in that figure, the triangle ABC, that's what you're given, and then you're trying to prove that those 3 angles inside that triangle add up to 180 degrees. So what we're going to do to prove that is we're going to draw what's called an auxiliary line, which let me try that one again, see if I can do a better job. There we go. That's that line, that auxiliary line is going to be parallel to one side of the triangle there, and it's also going to pass through that point right there, which is at point B. So when you do that, then you have a couple of other angles that are formed. Besides angles 1, 2, and 3, you have also angle 4 and 5 formed there with that auxiliary line. And so I'm not going to do a 2-column proof, but we'll kind of walk you through kind of an informal proof that you should be able to understand the proof of this theorem then. So you can see from the figure that if you say angle 4 plus angle 2 plus angle 5 equals 180, because those 3 angles add up to a straight angle. Right? They add up to a straight angle, so they add up to 180. And then also notice in the figure that angle 1 is congruent to angle, I'm going to write this off on the side, angle 1 is equal to angle 4, because if 2 parallel lines are cut by transversal, then alternate interior angles are congruent. You see angles 1 and 4 are alternate interior angles, because when we drew this auxiliary line, those lines are parallel, and then AB is a transversal. So angles 1 and 4 are congruent, and we can say likewise that angle 3 and 5 are congruent, or equal. Angle 3 is equal to angle 5. Again, because if 2 parallel lines are cut by transversal, alternate interior angles are congruent. So here, the transversal is BC. And so you see angles 3 and 5 are alternate interior angles. So if I take my original statement here in blue ink and I replace angle 4 with angle 1, and I replace angle 5 with angle 3, I have angle 1 plus angle 2 plus angle 3 is 180 degrees, so that proves that the angle sum of that triangle equals 180 degrees. Okay. Just in case you didn't see those alternate interior angles, remember that, I don't think I've told you this, but I should have. Alternate interior angles then are in the form of a Z. All right, so that's where you see the angles 1 and 4 being congruent. And then here's the other Z. So angles 3 and 5 are inside that letter Z. It's actually a backward Z. So they're alternate interior angles. Anyway, so there's an important theorem that we needed to know. Okay, so now we got some, I guess, a new vocabulary word here, corollary. A corollary is really a theorem whose proof follows directly from another theorem. So when you have a corollary, it's really a new theorem, but it's very similar to one you already proved. So here's our first corollary of the year, and that is the acute angles of a right triangle are complementary. We're not going to do a 2-column proof. I think we can talk our way through this one. If you look at triangle DFE, that is a right triangle. We now know that those 3 angles there add up to 180. So if you take the 180 degrees that all 3 angles add up to and subtract out angle F, which is 90, that leaves you with 90 degrees left over. Well, those remaining 2 angles, D and E, have to share that 90. So whatever they are, it could be 1 and 89, it could be 70 and 20, whatever they are, they do have to add up to 90, because that's all that you have left in that triangle. So whatever they are, they're complementary. They add up to 90. So that's a corollary, that the acute angles of a right triangle are complementary. Here's another corollary. Each angle of an equiangular triangle is 60 degrees. Remember that equiangular means all the angles of that triangle are equal. So now we know that all three angles add up to 180. And if they're all equal, wouldn't it be 180 divided by 3 to give you 60 degrees for each of the angles? So an equal angular triangle, each angle is 60 degrees. Okay, so let's dive into an example here. So here it is. One of the acute angles of a right triangle measures 22.9 degrees. What's the measure of the other acute angle? Well, you may not need to draw a picture, but I will just because we're kind of new at this. So here's a right triangle. So we know that one angle is 90, and this angle that they gave us is 22.9 degrees. And we just had a corollary which said that the acute angles of a right triangle are complementary. So that means that this other angle right here is going to be the complement of 22.9 degrees. So it's going to have to be 90 minus 22.9. Okay? So 67.1 degrees. Notice I do want to put that degree symbol on my final answer. I technically probably should have put degrees whenever I have an angle. But for sure, on your final answer, you should have degrees, the degree symbol. Okay, so there's a fairly easy example to follow. Okay, so we have some vocabulary here. So we see a triangle here with angles 1, 2, and 3 inside, and you got an angle 4 there, which is actually outside. So let's talk about some vocabulary here. So interior, so I'm looking at now, what does it mean to be interior? Interior is a set of points inside the figure. So right here, this is the interior of that triangle. The interior of the triangle is those points inside. Exterior is a set of points outside the figure. So these points out here are outside or on the exterior of the triangle. Interior angle is formed by the two sides of a triangle. Let me move this up a little bit. So an interior angle is formed by two sides of the triangle. So I'm going to highlight one of the interior angles. So angle 1 is one of the interior angles. You could have also had angle 2 is an interior angle because its sides are formed by two sides of the triangle. And we got angle 3, which is also interior. So angles 1, 2, and 3 are both interior angles. Now we do have an exterior angle here. So let's read the definition of an exterior angle, and then I'm going to highlight it. So an exterior angle of a triangle is formed by one side of the triangle and an extension of the adjacent side. Remember, adjacent means next to. So let me see if I can highlight an exterior angle. So that's one side of the triangle right there. And there's the extension of the adjacent side. So that's an angle outside the triangle. It's called an exterior angle. And we got a theorem about the really important theorem about that coming up next. So we just needed to know what interior angles were and exterior angles. All right. Okay, so the theorem we have for this situation, not surprisingly, is called the exterior angle theorem. And the exterior angle theorem says that the measure of an exterior angle of a triangle is equal to the sum of its two remote interior angles. Let me go back to the previous drawing here. So here, angle 4 is an exterior angle. Now, we said that the triangle has three interior angles, but these two right here, angle 2 and angle 1, those are called remote interior. Remote means far away, right? Remote interior. So the exterior angle theorem is talking about that exterior angle there, which you see, and saying that it is equal to the sum of the two remote interior angles. So that angle 4 you see there, which I've highlighted in yellow, is equal to angle 1 plus angle 2. That's what the theorem says, the exterior angle theorem, and we'll do a quick proof of that. So anyway, you got remote interior angles are the two angles inside the triangle that are farthest away from the exterior angle you're talking about. Okay, so back to this figure. So repeating, the exterior angle theorem, the measure of an exterior angle of the triangle, which is angle 4, is equal to the sum of the two remote interior angles. So we're going to prove that angle 4 equals angle 1 plus angle 2. That's what we're trying to prove there. Okay, so again, it won't be a two-column proof. It'll just kind of be I'll talk you through it. We know that angle 1 plus angle 2 plus angle 3 equals 180. That's the triangle angle sum theorem. We also know that angle 3 plus angle 4 equals 180 degrees. That's because those two angles form a linear pair, right? If two angles form a linear pair, then they're supplementary. Now look at my two red statements there. So they're both equal to 180, so you can set them equal to each other. So you can say angle 1 plus angle 2 plus angle 3 equals angle 3 plus angle 4. By substitution, if you're making a two-column proof, you say substitution. Now notice that you can subtract angle 3 from both sides. And when you do that, what you have left is angle 1 plus angle 2 equals angle 4, which is what we're trying to prove. So there's the exterior angle theorem. The measure of an exterior angle of a triangle equals the sum of the two remote interior angles. Okay, we got one more theorem. It's our fifth one today. And that is the following. It's called the third angles theorem. And what it says is if two angles of one triangle are congruent to two angles of another triangle, then the third pair of angles is congruent. So here you see two triangles, triangle LMN and triangle RST. And so we're given by the hypothesis of this theorem that angle L is equal to angle R. You see that I marked that off. And we also know by the hypothesis of the theorem that angle M is equal to angle S. And so we're trying to prove the conclusion, the part after then. And so we're trying to prove that angle N is equal to angle T. And then if we do that, we have proved the third angles theorem. Okay, so I'm going to write something that we already know. Angle L plus angle M plus angle N equals 180. It's a triangle angle sum theorem for the first triangle. For the other triangle, we have angle R plus angle S plus angle T equals 180. So that's the triangle angle sum theorem for the second triangle. Now both those equations equal 180, so we can set them equal to each other. So that'll give you angle L plus angle M plus angle N equals angle R plus angle S plus angle T. Okay, so if you look at what's given, angle R is equal to angle L, so we can subtract those from both sides. We're also given up there that angle M is equal to angle S, so we can subtract those from both sides. Oops, that's a T there. And so we're left with angle N equals angle T, which you can see that's what we started out to prove. So that's the third angles theorem. Okay, so to summarize this topic today, we have 5 theorems. One says the triangle angle sum theorem, that the sum of the angles of a triangle add up to 180 degrees. We have to know that. Then we had a couple corollaries, which you could also call theorems, I suppose. And that first corollary was the acute angles of a right triangle are complementary. The next corollary we had was the measures of each angle of an equal angular triangle is 60 degrees each. Then we had the exterior angle theorem, which said that the measure of an exterior angle of a triangle equals the sum of the 2 remote interior angles. And then the one we just proved here, the third angles theorem, says that if 2 angles of one triangle are congruent to 2 angles of another triangle, then the third angles are congruent. All right, there you have it. So let's go ahead and take some time and get started. We have 2 worksheets on this assignment, so let's go ahead and begin those and enjoy.